fill out this table so we can discuss it tomorrow. I would like especially examples. Today in period, sorry, in period 1, I gave an example like P plus Q, P times Q, not plus, sorry, P times Q to the 4th to the 3rd. Why can't we add them, the exponent? Because the base has to be the same. So in your definition, what does it look like? Characters, the base has to be the same, and no parentheses, right? But your own definition, or the base has to be the same in order to add. No exponent on the outside of the parentheses. Your own definition, product power rule, so whatever you write, when the base are the same, you can write when the base are the same, like this has P and P. When the base are the same, you add exponents, whatever you want to. Rules, we'll leave that later. Rules is generally like, I'll go over the rules. Use variables only. It's like P to the nth plus P to the m. So when the bases are the same, you add the exponents. So P is n plus m. That's how you do that. Quotient rule, start with an example. You know, you can give an example of a quotient rule, the one up here. If you have x to the 7th, I'm going to use y to the 8th, then x to the, and then y to the 8th. So what is your quotient rule? You subtract exponents when it's a division. So what does it look like? You may want to say it has a division bar. The fraction bar is a division bar. And the base has to be the same to subtract, whatever you can describe this for you to remember. It's your own definition. So here would be like x to the n over x to the m. So you can use any variable here that you want. And then basically you go xn minus m, like that. That's what you would do. Power to a power, start that out. Power to a power, you know, it's like 5 squared x to the squared to the 4th. And then you do examples. You got 5 to the 8th, x to the 8th. And you need to describe what it looks like and what's your own definition. Multiply the exponents, you know. You're going to do that. Power of 0, you can do 0 power, you can do y to the 8 over y to the 8 equals to y to the 0, which is equal to 1. Anything to 1 is, give another example. So forth for the negative exponent, you can do x to the 5th, y to the negative 2. So that is simplified to x to the 5th over y to the squared. Characteristics, you can write the characteristics. You see a negative exponent, you move, or that could be the rule also. And all you need to do here is go x to the n, m to the negative m, or y to the negative. No, it has to be x. The base has to be the same. Or no, I'm sorry, I'm thinking something else. So then you would do x to the n over y to the positive m. So you're just saying these can be any number you want. If it's a negative, you move it down. Positive, stay on top. Okay, and then you fill in the rest, all right? Now, who is correct? Period 2, we didn't do this, so who is correct? In this case, we say, explain why the other, who is correct? Who is correct? Nick. So determine which student is correct. The student that is correct is Nick. Adam is wrong because he added the exponent, or because he used the product rule, product of exponent rules. Which is adding exponents. Okay. Shane is incorrect because he forgot because h to the fourth minus 9 is not h to the fifth. It should have been h to the negative 5. Okay, so same thing here. Who is correct and why? Why is the other one wrong? Okay, who is correct in this case? Adam, right? Because 2 stays on top, W comes down because it's a negative exponent to turn into positive. And the other one is a negative exponent, so it goes up x squared like that. So Adam is correct. Nick is incorrect because he moved the 2, and the 2 has a one exponent, positive exponent. It should stay on top. Shane, I don't know what Shane did. He just changed, make everything positive. That's not correct. Who is correct? Adam is correct. Nick is wrong. Because he moved, because he should keep the 2 on the numerator. Shane is wrong because he should not have just made the signs different. Okay, you guys finish writing that. Okay, let's do this one here. Square root of 81 is 9. Okay, We can write p 18 times, or we can just divide by 2. I meant to put this q to the 14th. Divide by 2. So your answer's just negative 2 times 9, because square root of 81 is just 9. And p to the 18th power becomes p to the 9th, q to the 7th. Nothing remains inside. If you need to see it, 9 times 9 makes 81. And then we can write p 18 times. Pair out becomes 1 outside. Oh my god, I don't want to write p 18 times, only to show that each 2 to make 9 couple to come out. Okay? The square root of 144 is 12, because it's 12 times 12. 2 of them comes out, you have 1 outside. Inside, divide this by 2, you get m squared, remainder of 1, so m stays inside. N comes out once. Okay? This last one, 5 times the square root of 24. The square root of 24 is 6 times 4. Square root of 4 is 2 times 2. And square root of 6 we don't know. Okay, so then we got divide by 2 here. So we got p, so that's 10. 5 times 2 is 10. P squared q to the 5th power. Okay, and then here we got radical 6. Okay, page, that's the page. I'll quit this and I'll do the skills practice here on page 913 on the next video.